Welcome back to the deep dive. Today we're focusing on something you might think is simple, wire mesh.
Yeah, but we're not talking about your average garden fence here.
Not at all. We're talking about a really complex, highly engineered component that, well, it pretty much forms the backbone of global industry. Our sources show this stuff is everywhere.
It is, from deep sea drilling all the way to, the clean rooms and pharmaceutical manufacturing.
So our mission for this deep dive is to get into the key engineering choices.
Exactly. We want to understand the microscopic details that make one mesh perfect for screening gravel and another one suitable for filtering ultrafine powders.
Okay, so let's unpack this. The fundamental starting point has to be woven versus welded.
The big two, yeah.
When we talk about woven wire mesh, what are we actually describing? Yeah, it's like fabric, right? Metal wires, stainless steel, brass.
Just like fabric, they're interwoven, and the main advantage there is, well, twofold: flexibility and cost.
Right. It's cheaper because it's faster to produce.
It's much faster. And because it's so flexible, it's perfect for applications with irregular shapes, or
Yeah.
contoured filtration systems, things like that.
That makes sense. So conversely, the welded version must be all about rigidity.
Total rigidity. Every single intersecting joint is physically fused, welded.
And that's the key differentiator.
It is. Because those joints are locked, the mesh holds its shape perfectly, even under really high pressure. If you've got something you need to clean aggressively every day,
You need it to not fall apart.
you need welded mesh. It's far superior for that.
Okay, this is where the microengineering really gets fascinating. The design of the weave itself.
Yeah, we're going way beyond a simple over and under pattern here.
We're talking about things like crimps, which are designed to enhance stability. The sources highlight something called lock crimp mesh as the most stable.
Lock crimp is, it's supreme for structural integrity. The wires are actually pre-crimped before they're woven together.
So they're bent into shape first.
Exactly, and then they're locked into position at the intersections. This means they can't shift at all, not even a little.
So you'd use that for heavy industrial sieving or even architecture.
Perfect for both. Sieving gravel and sand, or for these sophisticated architectural facades where everything has to be perfectly aligned.
If lock crimp is so stable, though, there has to be a trade-off. Why isn't it used for everything?
Oh, absolutely. That pre-crimping process adds complexity, so it raises the production cost. Plus, you get almost zero flexibility.
You can't just contour it to a machine.
Not at all. Every choice is a specialized trade-off.
That's a critical point.
Oh.
Okay, what about another structure, the twill weave? It has that unique diagonal pattern.
Yeah, that's all about filtration precision.
How does the diagonal pattern help?
It creates what engineers call a tortuous path. So instead of a straight shot through a square opening, it forces material to travel further.
More winding path.
A winding path, right. It increases the surface area and boosts precision dramatically. It's ideal for separating things like pharmaceutical powders or filtering drilling mud.
I see. So for that kind of precision, you need high-end alloys. But what about when you just need volume and durability, especially outdoors?
Then you step back to the industry workhorse: galvanized iron, GI wire mesh.
Okay, that's the stuff you see everywhere.
It really is. It's highly cost-effective. The wire is coated with zinc, which provides that crucial rust and corrosion resistance.
So perfect for high-volume outdoor uses like, what, agricultural poultry cages?
Poultry cages, cluster reinforcement and construction, exactly.
So it seems like whether you need precision or just pure resilience, the right product delivers massive benefits. The sources mentioned high impact resistance, simple installation.
And this all ties back to globalization, you see. An engineer has to think about the specific environment.
Right.
A mesh used in Vietnam has to resist incredibly high humidity. One for Dubai needs coatings to handle extreme temperature tolerance. It's constant regional customization.
So it's clear that a seemingly simple decision, woven or welded, square or rectangular, it dictates performance in these highly specialized fields all over the world.
And that is the big takeaway here. Just think for a second about heavy-duty crimped mesh. The kind used in a quarry for screening massive loads of stone and gravel. That entire piece of infrastructure relies completely on an unseen decision.
An engineer choosing a wire size.
An engineer choosing between, say, a 1 millimeter and a 6 millimeter wire based on the exact load it has to bear. How much of our modern world runs on that one tiny engineering choice?